let us move straight onto our lesson for today. Now, guys, this first little bit, I wouldn't stress too much about taking the notes down. I would just wait until I'm done and then just take a screenshot of everything. Mostly because there might be one question about give a definition of this type of triangle or identify this type of triangle, classify it. But it'll be one question, maybe two if we're pushing it. But honestly, it won't be a huge chunk of your test or exam. And so whilst it's important to know this stuff, please don't stress about trying to get these notes down perfectly. Just take a screenshot. You can refer back to them later. Alrighty, so like I said, we focus very much in geometry on triangles. Obviously, there's so many other different 2D shapes that we can work with, and we do start to work with them more and more, especially when we start talking about quads. But our focus, especially in geometry, is with triangles, especially in grade 8 and grade 9. So I suppose the first question is, on like a basic level, what is a triangle? And I think we all sort of know, but in the chat, what is a triangle? Can someone in the chat give me a definition for what a triangle is? So you can put it in the chat for me. What is a triangle? Nice, guys. Well done. Okay, so most of you are saying it is a shape with 3 sides. Some of you are getting quite specific. 2D, it's a plane shape. And that's all great, all right? There's absolutely nothing wrong with that. But a triangle at the end of the day is a specific type of polygon that we work with. Okay, now, if you sort of enjoy English, or if you've sort of delved into why a triangle is called a triangle, this prefix tri means 3. So if you think about something like tricycle or triplets, tri means 3. Okay, so triangle means 3-angled polygon, and that's essentially what a triangle is. Okay, so a triangle is a 2D polygon. Let's maybe do that a bit better. Someone used another word in the chat, and there was a something like plane shape. I just want to find it because it was a nice word, and I have not really seen it used a lot. A plane figure. Basically, plane, P-L-A-N-E, basically means like on our Cartesian plane, we're linking coordinates up to form this 3-sided shape. All right, so it's a 2D polygon. Some of you are also saying it's a closed polygon. Perfect. That has 3 sides and 3 internal angles. And so internal, you can say interior, whatever makes you happy, I don't really mind. But that's essentially what a triangle is. So again, tri means 3. Think about tricycle, triplets. The only other one that I can think of is very like science-based, so we're just going to leave that. But tri means 3. Okay, so triangle, 3-angled, 3, not 2, 3-angled shape. And if we've got 3 interior angles, we have 3 sides. So if we were to draw a triangle, okay, now my triangle is not going to be the most beautiful thing in the world, but it's fine. We are going to look at specific types of triangles in a second. Here is exactly what you've said. We've got 3 sides. It is a closed shape. So all of my vertices or all of my sides linked together. And I've got 3 interior angles to my triangle. That is a triangle. Okay, now that is the basic definition of a triangle. We now can start to classify triangles according to certain characteristics that they have. Okay, so again, you can take a screenshot of all of this just now. Just let's sit and listen. We can classify triangles based on 2 different characteristics that they have. Either we can classify triangles based on their sides and the lengths of their sides, or we can classify triangles based on their angles. So we're first going to have a look at how we can classify triangles based on their sides. A couple of you are saying you can't see the screen. You need to log out and log back in. If you're still struggling, please let Yolanda know and she can help you further. Alrighty, guys. So these first three classifications are based on side lengths. All right, so if all three sides of our triangle are different lengths. Now, guys, remember, we know that we have equal lengths, different lengths based on these tick marks that are put on the shape. So this triangle has three different tick marks on its sides. And because of that, we know that all three lengths are different. When we have all three lengths are different, what we have then is a scalene triangle. So scalene means that all three sides are different lengths. What that then means is that all interior angles, so all three interior angles, are also different sizes. And if any of you have started to learn your triangle geometry reasons, this sort of makes sense. When we start to look at the relationship between sides and angles, we do see that depending on the length of a side, its angle opposite it does have a relationship. Okay, but a scalene triangle is a triangle where all three side lengths are different, and they therefore meaning all three interior angles are different sizes. So if we go to our diagram, we can now say that all of these interior angles are different sizes. You don't have to use the half circle shapes if you don't want to. You could use a dot, a cross, and a triangle, whatever you want, but they are different. That's what's the important thing here. Right, if we now step it up a little bit and we now get a little bit more specific, if we have a triangle where two of our three sides are the same length, so two of the three, if we look at our diagram, we've got two tick marks that are the same, so these two side lengths are equal. We then have an isosceles triangle. Now, this is actually one of the reasons that we're going to learn in this course, but it does also mean that the angles opposite the two equal sides are then equal in size. So the angles opposite equal sides are equal. So if we go to our diagram again, I'm just going to take all of that. These angles opposite these sides that are equal to each other are then also equal. So this angle is then equal to this angle. And again, this is a geometric reason that we're going to learn about later on in this course. It obviously then means the third angle is different from the other two. Okay, so scalene, all three sides are different, all interior angles are different. Isosceles, two of our three sides are equal, and the angles opposite those sides are equal. And then finally, we have the most specific type of triangle when it comes to the sides. This is where all three of the side lengths are equal in length. So all three of them are equal. We can see that because of these tick marks on the sides, they're all the same length. And guys, what that means is that all of the interior angles are the same, and they all happen to be 60 degrees. Now, again, when we start to talk about our reasons, we can chat about why they're specifically 60, but they're all 60 degrees in an equilateral triangle. And this will be the case for any equilateral triangle. It doesn't matter how big or how small it is, all of the interior angles are then 60 degrees. So if we want to classify triangles based on their side lengths, we've got a scalene triangle, all three side lengths different, an isosceles, two of the side lengths are equal to each other, and an equilateral, all of your side lengths are the same. Okay, so that's if we want to go based on length. If we, however, again, you can take screenshots just now when I'm done. If we, however, want to classify our triangles based on their angles, so this is if we're going to now classify based on angles. Okay, depending on the angles inside our triangle, we can give a classification, we can give a label to our triangles. So if we have a look at our first triangle that we have here, if you've got a triangle where all of your interior angles are less than 90, basically if they're all acute angles, shockingly, we have what we call an acute angled triangle. So if we look at our diagram, all of these angles in this triangle are clearly less than 90, and so we have an acute angled triangle. If we have one interior angle that is an obtuse angle, we have an obtuse angled triangle. Now, guys, we did go through types of angles a while back, but remember, an obtuse angle is an angle that is somewhere between 90 and, maybe let's use proper English here, between 90 and 180. So if, for example, we had an angle in this triangle that was 120 degrees, that is an obtuse angle. And so we then have an obtuse angled triangle. Right, and then a very specific type of triangle where if one of our interior angles is 90 degrees on the dot, so exactly 90 degrees, we then have a right angled triangle. And guys, remember, right angles or 90-degree angles, we can symbolize or we can show using that square shape. So if there's a square inside a triangle at one of the angles, it's telling us that it is a 90-degree or right angled triangle. Okay, so again, we can classify our triangles based on side lengths or based on angles. It really depends on what they've asked you to do. But most often we talk about scalene, isosceles, and equilateral triangles. I don't often personally talk about acute angled triangles or obtuse angled triangles. Obviously, we talk about right angled triangles a lot, especially when we talk about Pythagoras. But generally, we're going to talk about scalene, isosceles, or equilateral. But it's important to know all the classifications that we can have for a triangle. So I've just made this a bit smaller so that you can see everything all at once. You can take a screenshot of all of that information because, like I say, it's important to know because we might ask you to classify or identify the type of triangle, but it will be maybe 1 or 2 marks, 1 or 2 questions on that. It won't be worth a lot of marks. The application of the reasons is important. So you can use a protractor, but remember, most of the time, like 99% of the time, diagrams are not drawn to scale. And so what that means is that you can measure an angle, but it doesn't necessarily mean it's accurate. Often we don't draw diagrams to scale in geometry. It's often we have to actually go and determine mathematically, which is what we're about to do. Karabo, I have, no, sorry, I don't know what I'm trying to say. Karabo, I will zoom in a little bit now in a second. I don't really know how much you want me to zoom in, but hopefully that is maybe enough. Otherwise, I can zoom into the 3 sections in a second. But those are your important classifications. So guys, take your screenshots. Owetu, we are not doing Pythagoras right now, so let's just focus. I can't actually remember if we've done Pythagoras. If we haven't, it's coming up, but Pythagoras helps us with a whole bunch of different stuff in right angle triangles. All right, I hope you've all got your screenshots. I'm moving away. So just remember those terms, remember those classifications in case I ask, or in case your teachers ask, or an exam asks. Important to know. But what we want to be able to do is apply our geometric or our geometry reasons. And so we're going to have a look at our first triangle geometry reason, which is sum of angles in a triangle. Okay, so remember, guys, if you were with me for the last course, I said to you that I highly recommend you having a separate piece of paper where you're writing down all of your reasons and basically creating for yourself an information sheet. This is now what needs to go onto that information sheet. We're learning a new reason. It needs to go on the information sheet. So the first reason that we're going to have a look at is the fact that all 3 angles inside a triangle add up to 180 degrees. So if we had a look at this diagram here, we don't know what size these angles are, but if I took angle A plus angle B plus angle C, so I'm adding up all three of those angles, I will always get 180 degrees. Anytime you have a triangle, if you add up the interior three angles, you will get 180 degrees. Now remember, any geometric statement we make must have a reason. And so our reason here is sum of angles in a triangle. Some people use the reason slightly differently. So some people use interior angles of a triangle. Some people use, there's definitely another reason that some people use. I can't remember now because I don't use it. But as long as it is a reason that I have taught you or a reason that your teacher has taught you at school, I've got no issue if your reason looks a bit different to what mine looks like. But it has to be one either I've given you or your teacher's given you. So this is our very first triangle reason that we're going to look at, the fact that all three angles in a triangle add up to 180 degrees. Now, guys, if we just jump back, because I said it'll make sense now, if we jump back to an equilateral triangle. So remember, an equilateral triangle is a triangle where all three sides are equal to each other. That then means all of these angles inside my triangle are exactly the same. And so if we now apply this rule, technically what we have is x plus x plus x must equal 180 degrees. And so what we can do is we can set up an equation to prove that an equilateral triangle's interior angles do add or are all 60 degrees. Because x plus x plus x is 3x is equal to 180 degrees. Remember, we're solving an equation, so we would now divide both sides by 3. And if I say 180 divided by 3, I get 60. Okay, x is equal to 60. And that's why we said up here that in an equilateral triangle, all interior angles are 60 degrees. It's because they're all the same, and so all of them are 60 degrees. Now, you don't need to know that specifically, but I'm just explaining why we know anytime we have an equilateral triangle, all of those angles will add up to 60 degrees or will be 60 degrees. Alrighty, so here's your reason, here's your statement, take a screenshot. If anyone has any questions about this first reason before we start applying it, let's deal with it now. So you can raise your hands if you have any questions so far. Otherwise, we're going to have a look at some examples of how we now take this reason and we apply it to examples. Oetu? No, okay. Lindo?
Hi, ma'am.
Hi.
Ma'am, can I ask, ma'am, since all of these angles are not equal, how come do they all equal 280 degrees?
So remember, they don't have to be equals. This could be 20. This could be, I'm trying to think of, I don't know, this could be 100, and this could be 60. So they can all be different, but when I add them all together, I will always get 180 degrees when I'm working with a triangle.
Oh, thank you, ma'am.
Sure. Alrighty. Okay, so Anshia, I'm about to do some examples. Hopefully that'll answer your question as we go along. If not, please make sure you do ask. But basically, we're now going to calculate some angles when they're different sizes using our reason. Right, so guys, here's our first example. We've got a triangle. We have got 2 of our 3 angles. So we have been told that the angle bottom left is 70 degrees. We've been told angle bottom right is 40 degrees. And what we want to determine is x. So again, I never like to put instructions apparently. Determine the size of the angles marked with a lowercase letter. Right, so that's our goal. We want to find the size of the angles with a lowercase letter, and we now need to use the information that we've just learned about our reason of sum of angles in a triangle to do that. So exactly, every single triangle, it doesn't matter what the angle sizes are, any triangle, whether it's scalene, isosceles, obtuse angled, right angled, any triangle, all of the angles inside will add up to 180 degrees. Okay, now guys, remember this is geometry. So we have to give a statement, we have to give a reason. Remember, I've said to you before, split your page up into 2 parts so that you never forget to give your reason, because if we forget our reason, we are going to lose marks. Okay, I can guarantee you. You always get a mark for your reason. If you don't put it there, that's a problem. Grade 8, obviously what I have here is a triangle. I've got that closed 3-dimensional shape. Because I have got a triangle, I can now use the first triangle reason that I learned. So I know that if I add these angles up, so x plus 40 plus 70, I have to get 180 degrees, because in any triangle, when I add them up, I must get 180 degrees. Our reason, remember, always have to give a reason, sum of angles in a triangle. Again, if you have learned or if you have been taught a different reason, as long as it has come directly from your teacher and you're not making it up, then I'm absolutely fine with you using that reason. Now that we have this equation, we can now go and solve for x. Now, guys, remember, 40 and 70 are like terms, so I'm just going to add them together to make my life a little bit easier. So 40 plus 70 is 110 degrees. And we're solving for x, so we're solving our equation. That means I need to subtract 110 degrees on both sides, so 180 minus 110. Remember, inverse operations. And so x is equal to 70 degrees, because 180 minus 110 is 70. So guys, if we go back to our triangle and we fill in that information, here's our 70 degrees. Do you notice that we've got 2 angles that are 70 degrees in size? So have a think for me, and on the chat, what type of triangle has 2 angles that are equal in size? So think back to the classifications we did. What type of triangle has 2 angles inside that are equal? Put it on for the chat for me. Nice, grade 8. Well done. It is an isosceles triangle. If you've forgotten, let's just quickly jump back. Remember, an isosceles triangle has 2 angles that are equal to each other. We'll deal with the sides thing when we get there, but 2 angles equal to each other is an isosceles triangle. Very, very nice. Well done. All right, so guys, based on that, what I want you to do is give question 2 a try. I'm leaving question 1 up here for you in case you need it to help you. Let's try question 2 by yourself. Remember, you need to give a statement and you need to give a reason. Again, I'm leaving question 1 up for you so that you can see how we did it in case you're feeling a bit stuck. Remember, I did tell you, but just again, whenever you see that square shape in any polygon, you know that that means we are working with a 90-degree angle. So we don't have to write 90 degrees. We expect you to know that because there's that square there, it is 90 degrees. So answers on the chat. I want your answer and your reason, please. And guys, remember, you can check yourself. Once you have an answer, if you add whatever x is, plus 90, plus 46, we know we should get 180. So double check yourself and make sure that you are getting the correct sum of your angles. Remember those reasons as well, please. Some of you are putting them there, so well done. Thank you. Right, let's have a look. So again, we've got a triangle. We know 90, we know 46, we want x. So we can set up our equation. X plus 90 plus 46 degrees must equal 180. If we add all of the angles up in a triangle, we have to get 180 degrees. Our reason, sum of angles in triangle. Remember, guys, in your reasons, you can abbreviate. So angles we can abbreviate, and triangle you don't have to write out, just draw a triangle. Again, 90 and 46 are like terms. So x plus 136 degrees equals 180. Inverse operations tells me that I'm going to have to subtract 136 on both sides. So 180 minus 36. And so x is equal to 44 degrees. Now again, grade 8, I told you how to check it. Now that you know it's 44, quickly on your calculator, go and add 90 plus 44 plus 46. Make sure that you do get 180 degrees. If you substitute it in, you do, so it is correct. But there is a way to check yourself when you know what the sum should be. Alrighty, so take your screenshots. If anyone has any questions, please raise your hands and let me know what your question is. Otherwise, we will move on and have a look at another few examples. But this is the time to take screenshots, and this is your time to ask me questions if you need. Wandisile?
Afternoon, ma'am.
Hi.
Ma'am, is inverse operation and transpose the same word?
And sorry, you broke up a little bit there. Is inverse operation and?
Transpose the same word.
I have never used the word transpose, I must be honest. Let's see. What does Google tell me? Okay, see, that says it is. I want to say it is in somewhere in the back of my mind. I've heard that before in inverse operations. Let me just Google this. I want to say it is, but I also don't want to lie to you. So let's just double check.
Thank you, ma'am.
Yeah, I'd say it's fine. I will be honest, I've never used transpose, but it's fine.
Thank you, ma'am.
Pleasure. Okay, there you go. So yeah, transpose, inverse, whatever makes you happy, as long as you guys understand what's going on. I have just never used it. I know transposes they use in like university level maths, but I don't think I've ever used it in grade 8, but it's cool as long as you understand. Okay, guys, I'm hoping we've all got screenshots. No more questions. So let's have a look at question 3 here. I want you to give this one a try. Again, what you've been given is x, 130, and 20. I want to know the value of x. Remember your statement and your reason. You're giving it a try by yourselves. And on the chat, I want to see both your answer as well as the reason for that answer. Okay, which is also pointed out to us the fact that this is an obtuse angled triangle. We have an obtuse angle here. So it is an obtuse angled triangle. So very nice. Remember your reasons, please. And remember, you know how to check. You know what they should all add up to. So double check your answer. Make sure you actually agree with yourself. Nice, guys. Okay, let's have a look. So we know that x plus 20 plus 130 must equal 180 because of sum of angles in triangle. And because we know that, we can now solve our equation. So again, let's just add the 20 and the 130. They're like terms. Let's make our life easier. That gives us x plus 150. We're now going to transpose, now that I've learned a new word, and all inverse operations, and say 180 minus 150. 180 minus 150 is then 30 degrees. Okay, so x in this question, or x as our answer, is 30 degrees. Now double check yourself, guys. If we put 30 here, 130 plus 30 is 160, plus 20 is 180. We get what our sum of angles in a triangle should be, and so we know we've done our working out correctly. So you can double check yourself. Do double check yourself. Yes, you can use sum of interior angles. That's fine. Just say of triangle, because interior angles of what? Are you talking about a square, a hexagon? So just say sum of interior angles of a triangle, but that is fine. All right, guys. So again, I want you to try question 4 for me. It's a bit of a funny looking thing. My numbers were a bit odd. So x is this angle down in the corner here. You've been given 94 and you have been given 23. So I would like the size of angle x. Wait, we don't have a reflex angle here. Remember, reflex angle is bigger than 180. That is not possible in a triangle. So in triangles, we don't really work with reflex angles. And then I muted myself mid-sentence. You're trying question 4. Remember, exactly as Vashali has put on the chat there. That was a weird looking straight line. I do apologize. Statement and reason. So on the chat, I want answer with appropriate reason. Very nice, grade 8s. Good, it looks like we're getting this. That's awesome. I'll give you another minute just to make sure that you're all happy with your answers, and then we'll check. Alrighty, so x plus 94 plus 23 must give us 180 degrees, and we know this because it's sum of angles in triangle. Okay, because we know this, we can now go and work this out. So 94 plus 23 is 117 degrees. we're going to use our solving equation methods. I don't know why I'm shaking the pen as if there's ink in it. Okay, cool. I'm just going to move on from that. And so we're now going to inverse operations. 180 minus 117 degrees gives me an x value of 63 degrees. So as a lot of you said here, x is equal to 63. Simtanda, you can't just use angles in a triangle. That's fine. Yeah, it's fine. No problem there. Okay, so grade 8, let's take our screenshots of these two. If anyone has any questions at this point, now's the time to raise your hand and ask. Seems like we're doing okay with this. If you aren't, remember that's absolutely fine. It just means you got to practice. You can go rewatch the video if you need. There's also tons of resources out there, so you can go and practice. But ask your questions now while you have the chance. Otherwise, you're taking screenshots. You're welcome to raise your hand as well at this point if you do have questions. Otherwise, again, put them on the chat. Junior, no, they add up to 180. Angles in a quadrilateral, so in something like a square or a rectangle or a kite or something that has 4 sides, those add up to 360 degrees. So triangle, 180, quads, 360. Or where to, I mean, there will be from last year, obviously not, we've only just started this course, so there won't be this year's videos, but I think they should be from last year, yes. Okay, guys, nice. So, oopsie. We've done well. Okay, let us try. I know I'm skipping a little bit, but I want you to try question 3 over here. So question 3, I want you to try it by yourself to start off with. So question 3, remember all we're doing is we're solving for x. Yep. Statement with a reason. You have a triangle, so use the reason that we've learned, use the reason that you know. I want you to try this one by yourselves. I'll give you a minute or two, and then we will have a look at the answer. Taboho, I don't really know what you mean. How do we know angles are 360? What angles? Like, there's so many different angles that we can work with. Depends on the shape, but depends what you're trying to determine. So yeah, in a quad, there'll always be 360. It's by nature of what a quadrilateral is, but triangles are 180. Umpile, we got 117 by saying, I think it was 93 plus 94 plus 23. 94 plus 23 is 117 degrees. Guys, please also let's try and ask the questions when I'm on the question. Once I've moved on, we need to move on. So I give you time for questions. I wait while everyone's taking a screenshot. So please let's try and gather our thoughts so that we've got our questions ready to go. Roasting, no, it's not. It's always 180. Use that to solve your equation. If you have questions, put them in the chat. Right, let's see. So we've got our three angles. We know that if we add them up, so 40 plus 65 plus x plus 83, we must get 180 degrees. Sum of angles in triangle. So we now go and start simplifying. 40, 65, and 83 are all like terms. So that means I can add them all together. So I end up with x plus 188 is equal to 180. So yes, we've got 188, but that doesn't mean that all of our angles added together give me 188. I'm looking for x. So it makes sense that x should be negative because, as you said, you can't have 188 degrees, you can only have 180. So when we now go and solve this equation, we will use our inverse operation. So 180 minus 188, giving us an x value of negative 8 degrees. Now let's go and check, as I've told you to do before. If this is negative 8 plus 83 degrees, okay, so if we just go and actually simplify that, minus 8 plus 83 is 75 degrees. If we now add 40 plus 65 plus 75, we should get 180. Let's check. So 40 plus 65 gives us 105 degrees. 105 plus 75 gives us 180. So we get our 180 degrees, and that is because of the negative 8 degrees that I got. It is not often that we get negative answers, but in this case we had to, because as a lot of you pointed out, it's not possible to have 180 degrees. We can only get 180. So that value of x had to be negative in order to bring that third angle down to a size that would allow me to get 180 when I added together. Take your screenshots. If you've got questions, please do raise your hand and ask. Otherwise, we'll have a look at it one more. Lindo?
Hi, ma'am.
Hi.
Ma'am, can I ask, does it matter how you ordered it? For example, I mean, I said x plus 83 plus 65 plus 40 equals 280 degrees.
No, that's absolutely fine. Remember, the order in which we add numbers doesn't matter. If you say 7 plus 5, you get 12. And if you say 5 plus 7, you still get 12. So order of addition doesn't matter.
Thank you, ma'am.
Sure. Okay. All right, so guys, I'm just going to say that again. The order in which you add things doesn't matter. So in this first step, if your numbers are in a different order, so as Lyndall said, 83 plus 40 plus 65, rather than what I have here, it's fine. You get exactly the same answer. Okay, so we're taking screenshots. I'm going to wait another few seconds in case anyone has a question. Swallow, I don't really know what you mean. Will it be just like quadrilaterals? It can't be exactly the same because obviously quads are different, but we will use like similar methodology. So if we know that quadrilateral angles must add up to 360, we could use that fact to work out a fourth angle. So things change a little bit when we get to quads, but we do use their characteristics like we are doing here with triangles. All right, guys, so I want you to try this last one for me. I'm going to give you 2 minutes, give it a try. Let's see what we get for our value of x. Remember, statement, reason. You guys have done really nicely tonight. You've done a lot of independent work, which has been awesome. So well done. So last one. Let's see what we get for x. Great, I just want to say how well you guys have done, how amazingly well behaved you guys have been. Just looking at the people who've got their cameras on, seeing how hard you guys are working, it really is, like, you've made me very proud tonight, so well done. Watobe, you are looking for x, yes. Even though there's two x's, remember, once you found one x, they're the same value. Because they're the same variable, this x and this x are exactly the same. So once you found x once, you're done. Munira, there is a difference between quadrilaterals and triangles. They're two different things. So quadrilaterals are four-sided shapes. Triangles are three-sided shapes. So an example of a quadrilateral would be something like a square. We are going to have a look at quadrilaterals later on in this course, but they are different. Right, guys, let's have a quick look. Let's see if we all got the right answer.
Yes, please, because we're having a poll. Don't go out, guys. Wait, we're having a poll after this.
So x plus 100 plus x minus 10 must give me 180 degrees because of sum of angles in triangle. Right, remember, like terms, so x's are like terms, 2x, and then 100 minus 10 is plus 90, so 2x plus 90 equals 180. Inverse operations, 2x is equal to 180 minus 90, which we know is 90. Remember, 90 is half of 180. And then, guys, remember, we're solving for x, so we need to divide both sides by 2 in order to get x alone. And so x is equal to 45 degrees. Remember, check yourself through substitution. If you go and substitute in 45 in place of both of these angles and add them up, you will get 180 degrees. Okay, guys, let's take a screenshot.